Hi, welcome to today's lesson from section 1.2, real numbers. So this is going to be another section where we kind of skip around. The good news is once we get out of this section, we're going to kind of start to focus a little bit better on just one topic at a time. So hang in there. But real numbers. Basically, the real numbers are all the numbers we're used to working with. They're the numbers we like. They're fractions, which maybe some of you don't like. We're going to actually look at some of those here just a little bit today. But basically, the real numbers are everything. They're not really everything. There's some other weird stuff running around, but you know what? That's not going to happen in this course, so you don't have to worry about it here. All right, so let's start with number lines. A number line is just a line that represents all the numbers. 0 is traditionally put in the middle. Your positive numbers go out to the right, and your negative numbers go out to the left. So you can be asked to put a number on a number line, and it's not too bad. If you want to say, put 2 on the number line, you just put a dot right there at 2, and there you graphed 2. Now, what if you need to graph a fraction? So let's say you had 5 over 3. Oh no, where is 5 over 3? Here's a hint. You have a calculator? Type it into your calculator. See what the decimal looks like, and then all you have to do is put this in between, in this case, 2 and 3. This is going to be about 2.6, and those 6's are going to go forever. So just kind of put it somewhere in between 2 and 3, and it will really be close enough. I'm definitely not going to pull out a ruler to make sure you get it in the right place. As a rule, numbers get bigger as you go to the right. Okay, and a result of that is that every positive number is bigger than any negative number. So, for instance, 1 is bigger than negative 10, even though the 10 looks a lot bigger. Okay, so always keep that in mind. Basically, you'd rather have $1 than owe $10. So 1 is bigger than negative 10. All right, so let's get started with some fractions now. A fraction is just two numbers, one on the top and one on the bottom. I have them represented here with A and B. The number on the top is called the numerator. The number on the bottom is called the denominator. So it's important for you to know those words. I'm going to use them whenever we talk about fractions, so you need to be able to follow what I'm talking about. So make sure you know those words. Equivalent fractions. So equivalent fractions are fractions that represent the same number. Okay, so a really good example of that would be 1/2 and 2/4. So here's what I want you to do. If you're confused about that at all, draw yourself a pizza. Or rather, draw yourself 2 pizzas. Cut one into halves and the other one into quarters. If you shade 1/2 and if you shade 2/4, you're shading the same amount of pizza. So either way, you ate the same amount of pizza, no matter how you want to say, I only ate 1 slice. Yeah, but you still ate half. So anyway, those are equivalent fractions, and we're going to look at how to find equivalent fractions here just as soon as I change the board. All right, so equivalent fractions. We're still working on those. So I have 2 problems I want to take us through here really quick. We're not doing a whole lot with fractions here today. We'll do a little bit more after this too, but not too much more today. All right, first, I want to write 2/3 as an equivalent fraction with a denominator of 18. So the way this is going to work is we're going to need to multiply to make our numbers bigger. Okay, we want to go from 3 to 18 on the bottom, so we need to multiply to make our numbers bigger. We need to figure out what it is that we're multiplying by. So in this case, we can look at it and say, okay, 3 times 6 is 18. If you need help figuring that out, just turn it around and do a division problem. 18 divided by 3 would give you the 6. But here's the kicker. If you want equivalent fractions, you have to multiply the top and the bottom by the same thing. So we can't just leave the 2. We have to do 2 times 6 to get 12. So that's how we can make our fractions bigger. That's going to be used when we start adding and subtracting fractions. Now, the good news is that's not until section 9. So you have a little while before we start doing that. But it is coming, and that's why we're going to need to do it. The other thing we can do is we can reduce fractions. We can make the numbers smaller. This is beneficial because, let's face it, smaller numbers are easier to comprehend. So, in this case, when we reduce, basically all we're going to do is ask ourselves, what can I divide both the top and the bottom by? And it has to be the same number. Okay, you cannot divide the top by 4 and the bottom by 5. Even though 20 is divisible by 4 and 25 is divisible by 5. It has to be the same number. as long as you use the same number, either when reducing or making them bigger, you will get an equivalent fraction. If you use different numbers, all bets, actually, you just won't. You won't get an equivalent fraction. So here we have to decide what to divide both of them by, and the answer here is 5. And so we end up with 4/5. So there we go. That's how we can get equivalent fractions, either by multiplying or dividing top and bottom by the same thing. All right, let's continue. All right, so let's continue our work with the little bit of fractions that we're going to do here in this section, and then we'll move on to a couple other things to finish it up. First, to multiply fractions, we're just going to go straight across. So 4/5 times 6/7 straight across. 4 times 6 is 24. 5 times 7 is 35. Notice I did not bother to get a common denominator. That's only for adding and subtracting. We'll see that in section 9. What about if you just have 8? So you hopefully can see that I wrote the 1 in red. 8 times 1/5. Okay, that's not really a fraction. Well, you can put anything you want over 1 to make it into a fraction. We still go straight across and we get 8/5. We need to talk about reciprocals. A reciprocal is just a fraction flipped upside down. So for instance, if you have 2/3, its reciprocal is 3/2. Just turn it over. To divide, we're going to multiply by the reciprocal. So 9/10 divided by 2/3. The first fraction stays, so I keep the 9/10, but then I'm going to change it to multiplication, turn it over, and do times 3/2. If you go straight across now, you get 27/20. And so that's really all we're going to do with fractions right here in this section. We will do more fractions later. Okay, so I don't want you to think I'm just flying past them without telling you anything. There will be more later. Okay, just a couple more quick things to finish up this section. And if you need more, go back and look in your book, and feel free to send me questions. All right, so opposites are numbers like 2 and -2. Basically, they're the same distance from 0, just on opposite sides. So positive, they're always a positive and a negative, except for 0. 0 is its own opposite. So 2 and -2 will be opposites. Absolute value. Absolute value is defined to be the distance that you are from 0 on a number line. As such, since we usually measure distances as positive numbers, absolute value makes whatever goes into it into a positive. So notice I have 2 examples here. I have the absolute value, -7, and that's what these 2 straight bars are. Those are the symbol for taking an absolute value. Absolute value -7 is just +7. What happens if you put in something that's positive? Well, you just get what you had. Absolute value of a positive, in this case 3, is still that number. Finally, we need to look at something called an algebraic expression. An algebraic expression is different from an equation because there is no equal sign. Okay, so remember we talked in section 1 about how variables can be lots of different things. This y here that I have, 2y minus 6, it could be lots of things. It could be 1, it could be 5,000, it could be 2/3, lots of possibilities. But we want to pin it down here and say, what happens if y is 13? So all we're going to do is we're going to plug that 13 in. Now, when I plug numbers in, I like to use parentheses because it makes it easier to keep track of things, especially when we start throwing negatives into the mix here pretty soon. So I do that. I had 2y, which is multiplication, so 2 times 13 gives me 26. I subtract 6, giving me 20. So there's a lot of little things in this section. Good luck, and yeah, have fun. You're doing math. What could be better than that?